video we are going to discuss about quantum computers and quantum mechanics. I am Sri Kaleeswarar, an Tamil science writer. Let me dive into our topic. What is quantum mechanics? Quantum mechanics is a study of matter and energy at microscopic scales. Apart from these kind of slides, let me take a brief look at the fundamental physics. When in the 17th century Isaac Newton found out the theory for gravity, he had introduced a very novel ideology to the world of science. Afterwards, people think that we are living in a world, we are living in a universe which is certainly follows the same laws of Isaac Newton. Beforehand, we thought that the smallest splittable thing is called as an atom. Like Greek philosophy said that if we split a rock into tiny pieces, finally we arrive at a particle which cannot be splitted, which is called as an atom. But later in the 20th century, Max Planck, who is a great scientist and physicist, who gave the world famous constant called Planck's constant, also introduced the theory called quantum mechanics. The atom model of Bohr introduced a new perspective of approaching atoms. Also, we found out that atom is not just a single particle. It consists of proton, neutron, electrons, and when we take a deep dive into it, we finally found out there is a ton of fundamental particles behind this world of atom, which is called as particle physics. We have bosons, quasi-particles, and so on. Schrödinger, one of the greatest scientists in the physics history, who gave the wave equation which derives the function of a wave, which gave us a conclusion for the wave particle duality of photon, also known as light. Also, finally, Heisenberg, he gave the uncertainty principle, that we can't even judge a momentum and a position of a particle at the same time, which is still makes a contradiction in the world of physics. Even today, some people believe that this theory is not a great idea. But in reality, you can't judge the position of a car when it's moving. That is true. Quantum mechanics, actually, most people think that quantum mechanics is not only for very small scale objects. No, not necessarily. Quantum mechanics is for everything, but it is efficient and it is very much needed in the small scales. In other words, the real world which we are as a physical humans, we are directly interacting in the real world, like walking, jogging, or maybe traveling. We can derive all this stuff with the help of Newtonian mechanics or classical physics or classical mechanics. For the small scale quantum interactions, we need quantum mechanics for a very great review. But in the future, for sure, we will get a well-defined single theory for approaching each and every problem in this physical universe. Let me dive into our next slide. Fundamental principles, wave particle duality. We already know that the particle photon or light. It acts as a wave, but it is a particle. And here comes the superposition principle, also one of the great thought experiments called Schrodinger's cat. It depends about the superposition of a particle. Like when we put a cat inside a black box and kept a uranium, uranium uranium rock or a radiating rock inside the black box, there is 50 percentage of chance, like the cat may survive or may not. The Heisenberg's uncertainty principle defines the position and momentum of a particle which cannot be calculated simultaneously. Wave function representation gives the leads to the probabilistic determination of particles. Quantum computers use the law of quantum mechanics. Uh, well, actually, the classical computers which we are currently interacting right now, maybe a Ryzen processor or maybe an Intel i7 or an i9 processor, we use bits, simply the high voltage state and low voltage state, which is called as bits, and we are using a very precise fabrication of processes to make this interaction possible. For an example, I hope most of the people having smartphones in their hands. For an example, in your hands you are holding billions of transistors inside your smallest processing chip. It may be Android, it may be iPhone, or any other processor. We are holding with billions of transistors. On the other hand, for quantum computers, we use qubits, allows parallel quantum computation. In bits, we have two possibilities: it exists or it not exist, which is also known as 1 and zeros. If a particle exists, yeah, it exists. It may not, okay, that is 0. But in qubits, we can simultaneously look at both of the conditions. At one spin, it can be 0. On the other hand, it could be 1. That is called as a qubit. Allows parallel quantum computation. We can compute hundreds of values at the same second of or a same instant of time. Qubits can exist as 0 and 1 simultaneously, represented using quantum states. Measurement collapses the state, provides computational advantage. Maybe it sounds like matching, but it is just yet another marvelous innovation of quantum mechanics. Provides computational advantage. It may sound like a pretty interesting topic, but there is also it has its own limitations and issues. Let me look at those things. Entanglement and quantum gates. First of all, quantum entanglement, both as a 0 and a 1 state. Quantum gates manipulate quantum states. Like here we use Hadamard, PolyX, Synod. Quantum circuits execute algorithms. For example, currently we are using ChatGPT or GPT models, LLMs, and various kind of computational deep learning frameworks. But when we combine those to quantum computers, we can't even imagine the computational power of those stuff, because we are going to travel in the field of quantum states. But it has its own limitations. Quantum processors work at ultra low temperatures currently right now. So it is not practical to having a quantum computer at the Sahara Desert. Maybe you need a freezing cold environment to attain those stuff. Uses superconducting circuits. Like for superconductors, we need to have a very low temperatures, maybe at 5 or 6 or 2 kelvins, which cannot be possible in a physical world. It can be done with artificial things, or it uses trapped ions. Quantum states are extremely fragile. The thing is, we need to maintain the temperature at very ultra low conditions, and error correction is necessary. Since we are dealing with quantum computers, it gives us the way of possibilities. It may be wrong, and we have to be very careful with the quantum computing errors, which is a great and fascinating topic we will discuss in the next slides, maybe in the next video. Data safety and security, here comes the major role of quantum computers. Quantum computing threatens current encryption. RSA encryption may become unsafe. We already know that we are using 256-bit safety measurements for our bank accounts, financial stuff, and so on. Using native traditional bits level computers, we need millions of years to solve those formulas, solve those algorithms to crack the safety measurements of a computer. Like if we are having 256 bits of security, there is a billions of combinations we have to compute to get the exact value. But in quantum computers, it compares all the values at the same time and finds the exact correct pair and crack opens the bank security systems. In future, in maybe 10 or 15 years, current encryption techniques become outdated and we have to move to very great encryption techniques which can tackle quantum computers. We have to travel more on those things. Quantum cryptography improves security, which is currently developed. Post quantum cryptography is under development, and we will discuss it in another exclusive video. Future of quantum computing, it may be in AI and medicine, and also there is a ton of use cases for these quantum computers and quantum mechanics. It is useful in climate and material science according to ChatGPT. Thanks to ChatGPT for creating these simple slides for this video. Especially apart from climate and material science, the innovations become far easier for everybody when we are having a quantum computer on your table. The computational speed would be marvelous, enormous. So you can solve as much as problems as could much as at lowest possible of time. It can solve optimization problems faster. Uh, for for an example, currently still ML models are doing clinical trials, algorithms, maybe like algorithmic testings and drug development. In future, quantum computers can easily make a drug to treat a particular illness within 10 or 20 minutes. Maybe it may sound like a very quick time, but in future we can solve it way too much easily, because we can easily compare hundreds of combinations at the same time, like not hundreds of, I mean billions and trillions of combinations at the same time. So that would be like a fascinating research field in the future. This technology is still developing. We have to travel more on quantum mechanics in the future, and it requires strong mathematics and linear algebra. Knowledge of wave mechanics is essential. For this, you can use a ton of courses which is available in the online, and also in the future, upcoming days, I will going to teach about quantum mechanics in my own way to everybody. Like we will start from the classical mechanics, and we will take a dive into quantum world, like wave equation, Schrodinger's wave equation, particle natures, particle duality, and Poisson brackets. Also, we will take a look at the classical mechanics side, the Hamiltonian mechanics, Lagrangian mechanics, and other stuff to get a perfect view about the relation between classical physics and quantum mechanics. Quantum mechanics is a major future technology according to ChatGPT. It is not a major, it is a necessary future technology. We can expect that we will have language models which can even detect what you are going to think at the next extent. Like, it can predict what you are going to do next. That's true. You can register my words. It's surely gonna happen in the future. I'm not kidding at this point. With that computational analysis and using large amount of data, this quantum AI can easily predict what you are going to do next. That is true. In the future, there wouldn't be nothing privacy. In future, you can't even think on your own. That is going to happen when quantum computers going to approach the world. But still, we are waiting. And as a science writer, I always welcome the technology to get into people's hands. And I hope maybe in the future, within 10 or 20 years, we will have our own quantum computers in our homes. I hope this will gonna happen. And for students who are really interested about this quantum mechanics and quantum computers, you can take a degree on theoretical physics or general physics, maybe a master's or a PhD. That will enhance your work in the future. I'm hopefully sure that the fundamental of mathematics and physics will gonna rule the world in the future, and we have to travel way too more in terms of quantum mechanics and quantum computers. Quantum computers should be a milestone of quantum mechanics, not the extent of quantum mechanics. And also, according to my point of view, we should develop a theory which would be the theory of everything. Like, it will be able to solve each and every physical phenomenon, which can easily explain each and every physical phenomenon on each and every state of the universe. Like, maybe in the quantum state, or maybe in the quantum side, or maybe in the visible world, or maybe it can also define and explain the black holes. Apart from all the facts, thank you for watching this video. This is my own views and my own ideology also I have shared in this video. I hope I will make a ton of videos on quantum mechanics, physics, and other fascinating topics in the future. Leave your comments in the comment section. I will meet you in another lecture. Thank you very much for watching, and hopefully make a subscribe or kindly share this video